Oh no, I forgot to update the title. Give me a second. This is the 9th episode now. 9. Save. Great. It should automatically update. Let's see. Okay, it says 9 now. Alright, let's just get started then. So, that's what we got last time. Now, we want to finish off with the last thing. So what I've done is that while I was not streaming, I made a smiley face down here. You can see with that open. Smile.png. It does not look like a smile. It just looks like a guy staring into your soul. Oh, but yes, this is the thing that we're going to load onto it. So let's go and create a new texture. And the way we would do that is that we would go up here and we would go like just to go and EBO. There we go. And then afterwards we go up here, we create a separate texture. And we'll do is that we'll go new texture. Repeat. If be a little second. If text2.load smile.png gl_rgba, and we're going to force it to do that, is equal to -1, then return -1. But now the only other thing that we have to do is go texture where we draw stuff. So that we have to go, and when we go do this, we have to go text to us. Texture 1, I think, right? Yeah, no, you can't actually see the second texture. Do we need to map it as well? I forgot. Then OpenGL. Let's see. Yeah, we've done this, but let's see. Yeah, okay, so we load it, and then we go. Then afterwards we go bind the two textures. Gel bind texture should bind them both. Then we go draw. Oh wait, we forgot to do this part. Where are we going to use of shader? We have to remember to go. Here we go. In this case, we would want a second shader for that. So yeah, so how that code looks is a good question. we can quickly copy this as well. Before we load any images. Actually, give me a second. I think I left the yeah, I left the background on. Shit. It's the opposite way. Was my C. C++ projects. Cubic engines, PNG. I successfully did that, so it's good. Okay, if it's an HTML, let me just go copy this. Let's go, delete. Let's go and paste. Let's just bring that to a small PNG. And that's it. Next up, we want to go in and after this, we want to just make sure that it does that. And then let me look at the source code. So we have two, but oh wait, the source code is in the files now. It's really annoying, but essentially, yeah, we need a separate sampler. That will mix the two textures together. And I assume this is the opacity of both of them. So essentially what we can go and do is add in the second texture. Although why it wouldn't make more sense to just create a new one. A new, like, I don't know, rectangle, or actually circle in this case, and then draw it onto that, and just overlay that. I don't know why, but that just seems like a bad idea. Oh, for the time being, I'll just skip over this part, so we can continue, because I don't want to have to go and modify the source code too much. It seems to be working just fine, so yeah. Transformations, the part that I don't like much. Well, there's some stuff about stuff here that is very complicated, but we'll need GLM for this, so yeah. What that be in this case? Cubic engine. Include GLM. Oh, this is the source code. Here we go. How the fuck do you import this? Oh, it already comes with a folder, so I guess we'll just use it. Hey, go. Oh wait, this is what we need to copy. Okay, great, I figured it out. So this is the folder that we need to copy over here. Great, alright. Let's go in here, let's go import it now. Not here, but eventually the second texture load is pointless. This we can still keep. But yeah, we don't need to have this open either. We have to go into cubic.h, scroll up until we find the include, so we can just add a section for GLM. Then what? Matrix and transform.hpp. And then what? Type pointer, okay. Right, that's what we need to include. So alright, so let's start working on that. So before we go write any actual code here, we'll go for the code, we'll just go and write some back for back this is valid code GLM mat4. I'll just duplicate this code. So I assume the translate translates them to get all or something like that. I don't know. Why there is other text is oh, here we go. I know how to fix this. This is not a big deal. Run again. It returns 210. Okay, great. So we can use rotate and scale. And I assume radians means the amount that we should rotate it by. And scale is the amount that we should scale it up by. Alright. That's cool. It's cool that you can do this. So instead of just, I assume we'll need to replace this code. No, we'll need to replace this code right here. Why not? It should what? Oh, the declaration. Let's try to see. Okay, good. That's fine. 100. Oh no, it's 100 in this case. Alright, so yeah. So we have a transform here. Okay, so if this works, then this is the transformation that we want to use. And this is the output. In this case, this would be what the vec force for what exactly? Go like this. And we should have this in like, let's just do the color one for now. Wait. Yeah, I would like to be interested to see how these ones could work. And then afterwards, it's all of the positions and then 1.0. So instead we can output transform times, and this case 0 is looked as a plus, so we can just pass for a plus. And then we can go form times that. And now we just need to go and get it and change it. So luckily we don't have built-in functionality for getting stuff, only for setting uniforms, and it's done via a maybe we should have a vector file just for that. Down in our VBO we have one for no, it's in the shader program. We have one for setting uniform and one from setting uniform. So however, maybe we should have like a vector for or something like that. So like, what would a vector for look like? Would a vector for have fluid? This would be accurate. We just need a fluid A. Is that what you would use then? We'll take this away and then go up here. Vector 4, go this away, flip this away. Then instead maybe pass through a vector 4. I assume that this wouldn't be too hard to figure out. If we go, let's say vector 4 requires vec 4. I don't know what arguments that it needs. I would just call it that. We'll just call it A for now. Basically, instead of using colors, it now uses that. So instead of this one use that, it now uses a vector 4, just because that's vector 4 value, and that's it. That's basically the main change that has happened. Uniform name, here we go. Uniform value dot x dot y dot set uniform value dot k. So you can set the uniform value if you want to do. So now we should be able to with this code, right? Actually now main will have a couple of errors because no, we don't use that way of handling that. But now we would need some way to get and set it, so that's actually pretty straightforward. What we'll do is that we need to get it, so yeah, there's no way of actually getting it at the moment, only setting it. But we should be able to use, I don't know, some other function implement. It's set uniform matrix. And this one could just be color, to be honest with you. So instead of having to go through all of that work of using this, we will just have it be color set uniform. This one should just be like default vector for set uniform matrix. We can use geochart, shouldn't matter that much whatever we use. Uniform name. In fact, we can use geochart. It doesn't matter. For here, we'll just use geochart as well. I wonder what it says in the documentation. Shader program. It says that it uses. Oh, we haven't actually added set uniform. This is now a set uniform. This is now a vector. This use geochart uniform vector. And it should be of type vector 4 as well. Anyways, then in that case we should really quickly add in this case, right, the way it works is that it accesses it from an I assume refers to accessing a I. But in this case, get the uniform location checks both, right? Both shaders. So, I actually no. Isn't the uniform specific to Apparently not. Never mind. Yeah, in that case, we do need to. Actually, in this case, it's a uniform matrix 4. Matrix 4. Cubic. Okay, good. Uniform sampler constr char uniform name, and then a what do we want in? We want a GLN uniform value. What is it called? The sample 2D what? It's called a sample 2D. Uniform. That's all it does. Its parameters are pretty straightforward. You got the name. That's very straightforward. And then you got the GLIT uniform value, which I assume refers to the to when we set it, right? Which we do somewhere here. I don't remember where. I think it's like where down. Oh, I said we set it somewhere down. Yeah, here we go, right here. Texture stuff. Yeah, right here. And then the integer that it should be equal to, I guess. And then afterwards it should return. After this we want to have an insert uniform matrix. And this would in this case be what exactly? That's the thing that I don't get. But let's see. And we need to set a it's actually called matrix for. Oh, let's see. Params. I'll come back to this later. I mean, we can just keep this fully. And the second value, I don't know yet, so we'll just leave it at here, I think. Then we'll have the return type, the return stuff here. And then we'll have these two. So anyways, this is how it looks right now. Look, if you go, there we go. We got the uniform sample, so let's see, we need this right here. Uniform matrix for const. And we need the uniform name here. And this should just be a shape program. Wait, what does it want? It wants all share. Oh, this is where we pass for the share that we want to edit. But in this case, we can just pass for shader program, right? If not wrong. So or shader is just a shader program, right? So yeah. Then after this, we would need to call this. So we would need to get the matrices edited up here. Meaning we would need the vector that we're editing. Meaning we would just probably want to use and then we would need the what is it called? The mat4 there we go, that's the other thing that we need. And we're good. And of course this will have to return true or false, so right, the translock actually, if I'm not wrong, the translock it works by get uniform location as the same data. If form lock is equal to -1, it should mean that it's invalid from my knowledge. And then we will just go back in. And then go mat4 and that's all really that we need to do right now. So yeah, and if this fails, we'll go forget this, return -1, and then here we will return 0, meaning that everything works. And we'll continue that now. So let's go main. So we have all of this stuff right here, and now we would need to actually add it to the thing itself, meaning that after modifying it we will need to pass it through. So what we could do is that we could go general, is that could call shader program color shader program is what it's called now. Color shader program dot set uniform matrix form, and then go pass through, or name, which in this case would be transform, and then go pass through. Let's see. I mean, they're not even displayed on the screen anywhere, so I assume that's a bad sign that something went wrong. I don't know what it is, but something went wrong. Don't know what that would be. Oh, maybe we gotta put it instead of a loop. Give me a second, is the source code here? Oh, it's a very short one. But that's fine. If we go into our loop, do we need to put this within our loop? Yeah, we do, okay. We need to put this within our loop, that's fine. So again, we don't want it to be here, we want it to be down right after we've applied textures. Yeah, here we are. We have the transformations. Yeah, and we got this, and that's all we have for you. They do seem smaller, don't they? Like, let's compare before and after. Also, I can't tell if they've been turned kind of like squares. Oh yeah, they've definitely become half the size. If we compare it to a video that I had, like just here, you can see full size and half size. So they suddenly became half size. This is pretty cool. So again, we can use the thing to rotate and scale them without needing to write that code ourselves, which is very cool. So basically, this is our transform right here, which I guess we use to do all of this stuff. Now we just have to write some functions for this. So in our I don't know, I guess we can start creating some ways to rotate them. I guess we can create a function in our class that handles that. So like, I don't know, down like below texture, let's go. Let's call it object. So we got, let's say, an object class somewhere, all the way down at the bottom right here. Class object public we don't need anything like that. So object is just going to take in the object that we want to edit. So object needs, let's say, if we need a way to edit the object, so we need the yeah, that's it. So I assume this handles like positioning and stuff, so if I change this to 1, no, that does not work. Okay. Oh, it's because it's transformed now. Didn't for now. No, it didn't seem to do anything at all. I don't exactly know what the vector does. Listen, this is X, Y, Z, and I don't know what this is. But that should allow us to modify the X, Y, and Z. What? Maybe if I put in like, no, I don't know. Anyways, so yeah, we pass for vec3 to change its size. But what we need to do is make an object class that can handle that for us. So an object is going to contain the all the information that you want. We will have like the draw, and then we will go, and we will have a object that just basically handles everything for us. So we'll take in a, and then we'll go, hey, we don't want to define it here, an object function for that, and then go into our cubic. So we go object, and then we go and now the data that we want to pass through it, we want to pass through a EBO and so on. So we want to be like what? Draw is equal to draw. But this is not valid because we have no default constructor exists for draw. I mean, alright. We don't technically need to start with draw, but essentially we can make this like a static class object. or we can call it like map or something like that. So we have like the ability to rotate, to create and rotate and so on. So let's call it like map. So we have like a static. This should be a static class, by the way. Static. Oh, you can do it. So everything inside of it's static. 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 Map. Static mat for mat. We'll call this like mat for whatever. Mat 4, and let's see, we've been live for about an hour now, so mat 4, and then we'll go in and we'll close this down. Let's go in. So mat 4 should contain the code for mat 4. Mat 4. And it should just create a mat 4. So Joe mat 4. That's what it wants me to do. Yeah. So what we can do is that we can ask it to create, let's say, a transform by now. Let's see, call this like create. Or like, let's just call it transform. As this will create a transform for us. Let's call it mat form transform. So yeah. And oh no, don't want. Close. Thank you. That should be it though. So that will create all mat 4. We'll need another back 4. This will be a mat back 4. Mat 4 back 4. That's what it will be called. And it takes a vector 4. And what it does with that vector 4 is a good question. What we'll do with it is that we'll go in and we'll go static vec 4 mat 4 vec 4. We could also just call it drill. Vec 4. If I want to 2. Vec 4, and then go. What does it throw here? Oh yeah, it's because we need a vector 4, call it vec 4. There we go. this will just still return a vec4, right? Yeah, and then we'll pass through vec4 dot x, vec4 dot y, dot set, and vec4 dot a. So this will return a vec4, and then after that we will need a way to rotate and scale the object. So we'll use rotate GLM. We'll need to return a map form. We'll call it map rotate, and we would want to get the how much is radians exactly. It's just a float, so float degrees. And all this one will do is it will return rotate. We also need the transform as well, so we'll get the map for transform, and the float degrees. So has a rotate function right here, rotate, and it is going to take some arguments, but real quick, let me just go map rotate. Let me fix that. We go create a static rotate, and I'll take in a map for, we call it transform, and I'll take the float in degrees. Why this is not valid? I don't know. Come on. So what we need to pass through here is the transform. The degrees they want to rotate it, and a new vector. I assume that vector is referring to rotate. Rotate. At the transform, we got the axes, and then finally we need the axes, which in this case is just going to be another vector. And we need also a no, that's up here. We need that. We'll just pass this for the degrees and axes. There we go. Where's this not valid? It's the same exact function, though. I don't understand. This is the function that we use. Virtually the exact same. I don't know what's different. Yeah, it's the exact same. I don't know where it's throwing in there. So it takes in a float and we pass for the transform, which is matform. Then we play. Oh, it's Joe. That's why I forgot. It's radians that we're dealing with. But it's literally what it says. It says you must provide a rotate float. It's a const. Oh, those two are const for values. That's why. These two are const, and const. That's why. Am I still figuring out stuff? So again, it's const. It's scale rotate. It's const float const. You got the float. You got the two const. Oh, it's high p underscore mat4 and high underscore vec3. Let me. However, it shouldn't really matter, should it? Okay, what's one? Oh. This has to be a So why is this still fairing errors? Also, why is it giving me the unused documentation? So again, if I copy this right here, and I paste it over to here, what does this even return? Oh, it returns high, that's why. High. Now everything should work fine. We can pass through the float here. It can just be a vector. This is the please. There we go. It's working now. This instead is going to be the axes, so we don't have to be concerned about that. So we get the transform, the radians, and the axes. Great. Let me, technically we could just pass for mat for it. It should be the same thing. So yeah, shouldn't matter. This is what we have to return. I think we can probably get away with just returning forward. Yeah. In reality, it does not matter much, but let's see what changes have been made. This is no longer that. This is no longer that. This is a free, and that's it. There we go. There it is now. Okay. Mat for mat skill. And it also takes in what? Which I assume is referring to the axes, what? vec3 is referring to the in rotate there was some documentation on it, but here there's nothing. There's no documentation of it, so I'm just going to provide back. And we should probably go and make those two static. Vec3, vec3, happy vector 3, and afterwards also we need this one to just vec3. Then have a static mat for scale and have a const and transform and then that's all. Over here we're just gonna call this one a const. Oh wait, just leave it. This one is free. Here we're going to call this a vec3. Call it that. We'll figure out how to expand the functionality later, but this should be it. Just replace this code with all. Also, it's going to be a significantly simpler. So, first thing we'll do is to look at vec. When it comes to vec, I mean, and figure it out necessary. But I guess we could always just use vec. Yeah, there we go. So what we're going to do is that we're going to call we're going to call mat John. In this case, call vec. Go. Yeah. Okay. Make a vec and call it vec4 and make it equal to. Find a way to override the system eventually, so then afterwards we have wait, that requires vector instead. That's fine. We can just wrap this in vector 4. And here same thing. Instead we'll make it equal to mat mat4. Actually, I'm gonna rename them to transform4. As they're the transform itself, so they're going to just be equal to mat4. I have that. Mat4. In this case, mat4, and this is normally what you use, like what arguments does normally take. Here we go. Let's see what happens if we copy this. There we go. What? That's the const for x, so that would be x. We can just pass for a x in this case, so just go just pass for x again. And after this, we can just go back to here. We can go yeah. Then we all go into main. We'll just go pass for this. Then afterwards, we'll transform. It's the same thing if we just replace mat. It's slightly different, but what we'll do is that we'll need to pass through this, and we'll transform. And this does not need to be vec free. In reality, we could pass it through our own system. We can make a const vector free instead, if we wanted to. And then we can go and instead we can go vector vec free, and we can go and pass for vec free x. That's it. Do the same thing over here. Go instead we'll use vector, which might be a bit easier to get around. Vector free. Which also means that is there any errors here? No. We still will now just need to pass for vector free. There we go. This should produce the same result, if it works correctly, of course. And there we go, it does. So yeah, that's it for this tutorial. Really, there isn't much else other than a simple way of just rotating it like this. There isn't really much to go over there. The next thing would be to continue to the next page, which would in this case be coordinate systems. And oh, I'm not excited for this one. I looked into this one, and it's not fun. So yeah. So I don't actually exactly know how these functions work, so I think I'm going to do research on how the underlying functions work. And that's what I think I will have to do for next time. Where do we have our to-do list? So before we actually go 3D, we will do that. So I'll add like a to-do thing up here. And this will be the thing that we gotta do. Anyways, I hope you guys enjoyed this. I guess this is my first ever time experimenting around with GLM. So yeah, it does look quite complicated, but I'll do some research. So hopefully it won't be as complicated when I come back again. But yeah. Anyways, once I have a better understanding of it, I'll come back and we will continue. Also, yeah, let me append this to GitHub, and then we'll work on coordinate systems later on. Probably not next time, but still maybe in like a couple of times. So yeah, anyways, that's all I did. Commit, push. There we go. Close. Fresh 11, great. And where's it? I put that. OpenGL mathematics. There we go. Yeah, we just got past transformations and textures, so that was quite a bit for today. But yeah. So wow, that was an hour. I think I'll see you guys next time. Goodbye for now.